So I don't know how long I've known Tim. There's a long-running joke with someone else in the crowd that I've known them like my whole life. I haven't known Tim my whole life. However, Tim is a legend when it comes to WebRTC, tinkering with things that other people wouldn't even dare to tinker with. And he's one of the people that I go and ask when I'm stuck on anything WebRTC related. So thank you very much, Tim, for being here. And over to you.
Yeah, so this is a talk about race cars and WIP, video distribution from race cars. You can contact me on like any of those channels. So I'm Tim Panton, I'm the CTO at pi.pe GmbH, and it's a German company that licenses a WebRTC stack for small cameras, things like baby monitors, security cameras, things like that. And we have a patented algorithm method for doing edge-based authentication, which kind of removes the need for a honeypot in the middle with all your tokens in it. So, but that's not what I'm talking about today. What I'm talking about today is WIP, which is an IETF active draft standard, which actually is much further along the process than it sounds. Active draft is very close to being fully standardized, which you can see from the timeline. We're kind of almost there. And what it does is it's a standard for taking audio and video from a remote endpoint and transporting it into a central point for distribution, either distribution or production. And its kind of unique feature is that it does this at low latency and over what you might think of as questionable networks. And low latency is such an ambiguous term, I'm going to be specific and say less than 500 milliseconds. It's not always less than 500 milliseconds, but that's a kind of differentiator from things like Dash and stuff like that. And the other thing is that it's WebRTC based, so it has browser compatibility, which is kind of nice from a bunch of reasons. So the thing about standards is that they will give you, or if they work, they give you an ecosystem of products and services that you can buy that are somewhat interchangeable. And from that mark, WIP is already somewhat of a success in that there are like video conferencing apps that will take WIP ingest, like Ghislaine and Janus. And the numbers in brackets are the rough glass-to-glass latency that I measured. I mean, it's not an exact number, this, but it gives you a sense of how low that latency can be. And then you've got things like video production apps, like Dan's Broadcast Bridge and others. And then you've got video distribution, so you can send a single stream into a video distribution service, and it will send it out to 10,000 users or whatever. And you've got people like Twitch. Now, they're much higher latency because they then transcode it to HLS or Dash, and so you end up with kind of that kind of latency. But at least the ingest is quick. And then you've got Cloudflare, who have their Stream API that does WIP, and Dolby, who have the same. And there are others who I've missed or I'm under NDA with, so I can't talk about. But there's an economy coming, ecosystem emerging here, which is really positive, I think. And then on the other end, you've got sources that generate WIP. So you've got things like remote production facilities like OBS, and then if you've got a camera that doesn't do WIP, you can buy an encoder that encodes it to H.264 and sends out WIP. And then you've got a bunch of open source, things like GStreamer. I wrote a very simple thing called Whippy that runs on a Raspberry Pi and turns it into a WIP source. And then, of course, smartphones. Every smartphone on the planet has a WebRTC-capable browser that is capable of being a WIP source. So like all your influencers out there can be WIP sources. And then you can have a camera that is dedicated to built to do WIP, and which is where we get to here. we've been doing these baby monitors for, there's, I don't know, 40,000 of them out there, for a while. And somebody came to us about 18 months ago and said, you know that code you're running in the baby monitor, can we run it in a race car? And I'm like, well, maybe, why? And they wanted to put it over the shoulder of the driver so that you get a view of the track from the driver's viewpoint, and at low latency back to the pit, so the pit crew could see what the driver can see and give advice over the radio. Maybe the pit crew might include a training, an instructor, or it might include an engineer who's added a new feature to the car or something like that. And so this is a low latency, high quality feed to the pit and the trailer. The thing that we found though is that the range that we're talking about for this is a couple of kilometers, in that the diameter of these tracks is typically a couple of kilometers. And these things move quite fast. So we couldn't use Wi-Fi. We ended up using public 5G networks, which is what this camera is. And just a side note, very quickly on the on this, how fast is 250 kph? Well, the answer is it's too fast for the GPS. You can see that it went. The GPS told us that this guy had jumped the river, and he hadn't. So a peek inside this camera. It's a 8-core ARM, 2 gigahertz ARM device. Nice spec. Lovely thing is it's got a slot in it that you can put a PCIe 5G modem. So that is a complete 5G install there, running actually on Vodafone right now. So I've been talking about WIP, been talking about this camera. So obviously this camera runs WIP. Well, actually it doesn't. Not really. So why doesn't it run WIP? And this is an illustration of places where you would or wouldn't use WIP. And the answer is that we wanted to trim out some latency. And WIP is a centralized service, or you always have to go to a server. And in the case where you have a private 5G network covering a racetrack, both ends might be on the same private 5G cell. And that means that we would be losing that advantage by going back to a central server and back again. So that was one reason. The other one is that WIP is very much focused on media. It doesn't do the data channel. And we wanted to use the data channel. We've got a GPS in there, as I said. We've got a G sensor, we've got thermal measurements, and we can do camera control over it. And in theory, we might do bidirectional audio. It actually turns out the radio is a better channel for that. So if you look at that in terms of the network diagram, it's on the left, I guess. In the car, you've got a Linux machine with our WebRTC stack and talking over standard interfaces to things like the camera and the other stuff. Signaling's via the cloud, but the actual data and video and audio is peer-to-peer to a web page sitting in the pit. But then what we do is we reflect the video out from that, and potentially only the video, out from that to a WIP service. We send a single stream from there to a WIP service, and then on that WIP service you can get tens of thousands potentially of users. Typically not. Typically they're the VIPs or the owners or that sort of category of people. So it's a quite narrow user base, but you know, you might be thousands, and we certainly don't want to be doing that. So now I'm going to try and see if this thing's actually working. And whilst that's not loading, we can ask ourselves, or you can ask yourselves, who Mardenborough is. And it's not loading. Have I got internet? Let's give that one more shot. Yeah, no, I'm plugged into the Ethernet here. So in theory, it should be doing that. But it doesn't look like it is. Let's just see if we've got a ping. No, but I do have a ping. So why is this not working? Right, well, we'll skip that, come back to it and see if it's revived itself in a bit. Oh, come on. No, it's unhappy. Oh, wait, no. We're not even getting to that. Right, okay, back to this. So one of the things, as Dan was saying, I kind of do stupid stuff. I agree to doing stupid stuff, and that was one of them, obviously. So in theory, maybe if we get this working, I'll show you it later, but basically the idea is that you could do one-to-many on that. We can do... actually, it's really annoying, I can't show you this, but like, there's a drop in that page, there's a dialog where you can configure where the WIP service is. So I can replace the WIP service at will just by configuring it in there, and the where it goes to is controlled by that. And that gives me multiple providers, and I can choose the scalability, but it's nice that it becomes somebody else's problem. And our experience is that it works pretty well, actually. I mean, if you can connect to the thing at all. It does add about another 100 milliseconds in glass-to-glass latency, but that sort of doesn't matter because the people who are watching it are not at the track. What we found is that the people who are at the track can actually hear the gear change in real life, and so having it out of sync on the screen is very disconcerting, whereas the people who are remotely, maybe the owner or whatever, is maybe half a continent away. So 100 milliseconds latency doesn't bother them so much. So the reason that we need WIP is actually somewhat my fault, in that there is no standard signaling in WebRTC. Like, the standard doesn't have a standard signaling mechanism. And I and a few others blocked that in the standardization process, and I'm not apologizing for that. It was the right thing to do, and you should be thankful, because if we hadn't done that, you'd all be trying to use SIP in the browser, and it would have been a superset of SIP, and it would have been completely useless for all of the other things we're doing with WebRTC now, other than plain telephony. That's my opinion, and I'm still not apologizing for it. But it does mean that WIP is just a wrapper around WebRTC, which gives you these nice attributes of being tested and low latency, and there's a huge deployment out there, and that it works over real networks. And in fact, even more than that, the networks are forced to make it work. Like, they want things like Google Meet to work. So if you're an ISP, you have to have Google Meet working in your network well, because it's a requirement, which means that we freeload off that, basically, because WIP is using the same wire protocols. So it is complex, but WIP hides most of the WebRTC complexities, not all. So one of the things you can think about for the video distribution WIP services is that they fall into two categories. There's basically the category of services that re-encode, and those who are pure forwarders. It's kind of like the MCU, SFU distinction. So Twitch is definitely a re-encoder, and Ghislaine and Cloudflare are definitely forwarders. And it's about what they do with the packets, how much they unpack them and repack them. It's a slightly, I'm drawing a hard distinction here, and actually there's a bit slightly more blurred than that, but I think it's a useful way to think about it. So for the re-encoders, the strategy you have is that you send the video at the highest possible resolution that you can get out of your device and into theirs, and then it's their problem from then on. They will re-encode it into multiple bit rates for multiple devices. They'll possibly generate different multiple protocols for consumption by different devices. And so it's kind of not my problem at that point. They will deal with all the PLIs, the full frame requests, the RNACs, and all of that. But they'll add 100 milliseconds latency, or if not more. And the config, the choosing of the config, is slightly more complicated. If you look at the Twitch setup, there's quite a lot of checkboxes about like how low latency you want it, what services you want to do, stuff like that. Then the converse is the forwarders, which are kind of like the SFUs. Basically, you have to send them, everything you send them is what they're going to send to the end users. They're not going to make anything new, which means that if you want multiple bit rates to multiple different end users, you have to send them all. Now, they'll selectively forward them, but you have to have created them, which has higher bandwidth requirements because you're sending multiple. You're sending a simulcast stream with multiple streams in it, and that's raising your bandwidth requirements, which may be a problem. It's also raising your CPU, GPU, because you're encoding at multiple bit rates. You need to deal with the PLIs and full frames as new joiners arrive. But the bonus is you get considerably lower latency, and you're absolutely in control of this, provided you're willing to munch some SDP to get exactly the bit rates and behavior you want on the simulcast. So I did a little bit of digging into what SDP various services give back. So the deal here is that we sent a Chrome offer, like with all of the things that Chrome is prepared to do, and then to each of these services to see what came back. And it's quite interesting. For all that they all do nominally the same thing, the responses are different. Like Ghislaine, unsurprisingly, does normalize because it's like not as much of a centralized service as the others. The others all do isolate only. And then for IPv6, rather surprisingly, neither Dolby nor Cloudflare's streaming service offer you an IPv6 candidate. I was genuinely surprised by that. I thought they would. And I was even more surprised to find that Twitch does. The star with Ghislaine depends on how you deploy it. If you deploy it with IPv6, it'll give you IPv6. If you don't, it won't. So it's kind of up to you, and whether you configure it or not. H.264, everybody does H.264, or supports H.264. Dolby, amusingly, supports it 3 times in different profiles, which, again, was somewhat of a surprise. But it means that, in theory, you could send like a low profile for older devices and then a higher profile for more modern devices. And you could send multiple streams like that. Everybody supports VP8 except Twitch, who are H.264 only. Then VP9, again, Twitch don't support VP9, and Ghislaine's not very happy about VP9. It comes and goes in whether it's supported or not. Only Dolby support AV1. Now, it's kind of interesting because what you might have is you might want to use AV1 for the lowest possible bit rate and then use other things for the higher bit rates. So you can send multiple codecs at once, multiple different codecs in your simulcast, which is potentially interesting. And then finally, again, RTX. I thought about this afterwards, and I realized that actually the reason that Ghislaine and Twitch don't do RTX is they're both the same code base. And Panton and actually Pipe don't really see the need for RTX. There's a bonus in supporting. So RTX is this thing where if the far end has sent a NAC saying it's not seen a packet, you can resend that packet. And you can either resend it just resending it, or you can wrap it up in RTX and send it on a different M line and say, like, this is a retransmit. Statistically, that's better, or it's easier for it to build up to do the statistics measurements if you do that. But it makes very little difference in practice. So neither Panton nor ourselves bother to do that, and both Ghislaine and Twitch are based on Panton. So kind of quick summary here is when you're thinking about using WIP, the question you ask yourself is, or you need to know that WIP is something that sends unidirectional media over a variable remote link at low latency. And if that's your use case, then you should be looking at WIP. If it isn't, then don't bother. So you decide first if that's your use case, and then you need to decide how many watchers have I got, what will those watchers be using, what kind of networks will they be on, and therefore what bit rates and resolutions you need to offer and generate. And from that, you can then go back and work out which service will do the best thing for you. Or you can do what we did, which was that you can prototype with a bring your own. We prototyped with Ghislaine. We can prototype it with Ghislaine, and then once that's done, we can move to a production service if we need like 1,000 users or something. So thanks very much. I don't know what we're going to do with questions. Dan will probably tell you. I'm open for doing WebRTC consultancy and, as Dan says, stupid projects, risky projects. And I'm also down for building stuff with Pipe. Contact me, Tim at Pipe, find me later. Steely Glint on Chaos Social. Yeah, that's it.